YouTube world. Once again, this is Dr. Satish Singhal, PhD, Professor of Computer Science at El Camino College, Torrance, California. This is my fifth video in this series, User-Defined Functions in C. And in this one, I'm going to talk less about functions, but a lot about character pointers passed to functions. Character pointers have some very amazing and special properties in C language. They can store one character address, or they can store address of the first character in a string of characters, which is called a string, and get access to whole strings, print each individual character from the string, or print the entire string, or print address of each individual character. There are so many different facilities. Not only that, you could do it in so many different ways that it's just mind-boggling and head-spinning. I'm going to keep it simple today. I'm not going to use every possible way of manipulating a string in C, but in time that will become possible. Okay, so what happens is that character pointers are given a special facility in C language. Not only a character pointer can store address of one character, it can, by that property, access also every character in a string of characters. For example, this is a single character example. I declare char C equal to R. Then I declare a character pointer ch and give it an address of C. In that case, this is the pointer ch, and C is its pointee, which is storing R. So pointer-pointer relationship is established. You remember my diagram for a couple of videos ago how pointer-pointer relationship works. And if I do printf %c, dereference value of ch is going to print R. Well, actually I can show you in Xcode right now that it does. I have a lot of code here. Or did I get rid of, actually I got rid of this code. I can copy and paste that code right now and show it to you that it does work. It was there after all. And I'll do C in dot get here. So my program will stop there, and let's, oh, okay, I'm sorry, that is C++. Let's do get char then. And can you see it printed R because we gave stored address of C in ch, and then we printed dereference value of ch. We got R, which is the pointee of ch, pointer-pointer relationship. And of course, you remember that very well that we did in previous video, or maybe a couple of videos ago, that if there is an integer pointer, once it stores address of that integer, once an integer pointer stores address of an integer, dereferencing that pointer, you can print its value. We've done that many times, so nothing new here. Only more exciting to see that things work a certain way. Okay, I just wanted to hide only this portion, but I guess that didn't work. Okay, fine. Now, the other thing is that there's additional facility allowed to character pointer is that a character pointer can store address of first character of a string as below. If I make a hard-coded assignment like this, then str is actually a character pointer, but it's storing address of A. But in the RAM, A, B, C, D are contiguous right next to each other, and each one of them is 1 byte. So once it stores address of A, it can actually get access to B, C, and D also by adding something called 1 to this address. 1 doesn't mean just number 1, it means that it has to jump, actually in this case it's just one byte, that it has to jump by size of that data type, okay? And we'll show that to you in a minute. And the third facility that character pointers are given, that once a character pointer points to a string, you can actually print it without dereferencing. By dereferencing, you can print each individual character, but to print entire string, you just need to use the pointer, which is a little bit counterintuitive compared to what we have been discussing so far, but it's a special facility allowed to character pointers so that you can print them to console without much problem. And not only that, when you make a declaration like that, something else is added to the end of the string automatically, which is called a null pointer. Okay, we are going to demo that and a few other things in Xcode, and in the end we are going to talk about passing large block of memory to a function through a pointer. Okay, let's go to Xcode. Okay, so imagine I'm also going to show you some behind the scene things that happen, the theory. Imagine that, thought there's a way to fold this, just this one, I guess not. Imagine I've declared a character pointer str like this. So what it does in the RAM is as follows. Here's my pointer. Actually, that should be 9894. Here's my pointer called str in the RAM somewhere. And once this assignment is made, it's going to store at first block, actually in this case, its whole thing is 1 byte. So it's going to store address of A, which is 9894 here, and then it's going to point to this entire string, of course. But the way strings are set up, C strings are set up in the RAM is that if you have A, B, C, D, if first byte is 9894, A is contained at 9894, then B will be contained at byte number 9895, character is 1 byte. C is contained at address 9896, which is starting address, and the whole thing is 1 byte actually. It doesn't matter how many stars I'm showing. And then D is contained at address 9897, and then C automatically adds something called a null terminator at the end of a string that is put inside a pair of double quotes. Okay, so all C strings are automatically null terminated. You don't have to add that physically, they already are. That's the structure. Now the great thing is that if I can get this address, which is really address stored in str, I can just add 1 to it and I'll get to B, and I can add 2 to it, I can get to C, I can add 3 to it, I can get to D, I can add 4 to it, I can get to this. Of course, this works even if these were not 1 byte. We'll show that someday when we talk about arrays, array of integers, adding 1, 2, 3, 4 will still work. But right now it's actually perfect. Each character is 1 byte. Address stored in str is 9894. If I just dereference str, I should get address of A. If I dereference str plus 1, I should get address of B. If I dereference str I'm sorry, not dereference. Dereference will give me the value ABC, but if I just print str plus str, I should get this address, str plus 1 this address, plus 2, plus 3, plus 4, like that. And that's indeed the case. We'll see that in a minute. Let's see a couple of lines of code and then we will see them. First of all, I also want to say that literal strings also have an address. You can't get hold of those addresses more than once, of course. If I print x, y, z, t, it's a literal string. Of course, this is not the same as this one. There are two different ones. It'll, of course, print x, y, z, t onto the console. But if I put a literal string x, y, z, t here and put ampersand sign in the front, well, it's going to print address of the first character of this one. Let's just see that one first. And we'll stop right there. Let's just see that much. Okay. And you can see this line printed this one, and this line printed the address of xyzt, which is this one. Okay. All right. So address could be printed that way. All right. Now, as I go along, I'm going to comment things out so I can just focus on the relevant things. Okay, so we set str pointer to ABCD. This is a special facility allowed to character pointers, that if a character pointer points to a string, not a character, point to a string in this case, if I do this syntax where format string is S, it's going to print entire string. And if I notice, to print entire string, you don't have to dereference. Okay. And this str stores the address of the first letter A. So that's being printed here as well. No, actually, sorry. I'm going to show that to you in a minute. Address issue in a minute. This will print ABCD. But if I do dereference value of str, which is storing address 9894, then it should only print A. And you will see it does. Okay, can you see? We had assigned character pointer str abcd. When I say printf format string s str, it prints entire string. This is a special facility allowed to character pointers, that if they are pointing to a string, using their name can print the entire string. But if I want to print the first character, notice that 9894 is stored here. If I do dereferencing, asterisk that, it'll print only A, not the entire string, because it's storing address of only this one. And that's what happens. This prints A. Okay. Now I'm just going to do this sequentially, that I'm going to print a character one by one in this string and print its address of each character as well. And that will, of course, also prove to you that addresses are 1 byte, characters are 1 byte. So we're trying to keep this picture in focus, as well as, okay, good, I got everything, as well as the rest of the code. Okay, so in this statement, I'm printing A because str is storing address of A. If I do dereferencing on str, I will print A. Since str is storing address of A, if I do print str itself, it should print address of A in the RAM. But B is 1 byte more, so str was 9894. If I add plus to it, I should get to 9895. And if I do dereferencing on str plus 1, it should print B. And then if I don't do dereferencing, I print str plus 1, then it should print address of B. And if we keep going like that, str plus 2, dereference value of str plus 2 should print C, and straight str plus 2 should print address of C, and dereference value of str plus 3 should print D, and str plus 3 straight should print address of D. And 4 is a null terminator. So if I do str plus 4, which will be this address, is dereference value. Actually, it's not going to print anything because null terminator is not printable, but it'll give you address. Okay, so why am I doing this? Let me not. Okay, I call the print function. Okay, I'm not gonna do that right now. I'll do that later. Okay, so let's see output of these 2, 4, 6, 8, 10 lines. And let's keep this picture in focus as well. So there we are. This line prints A because str stores address of A. So when I dereference that, I am able to print A. But str itself stores the address. When I print that, I get address of A. This address will be different from that because these are fictitious address. Each time, of course, it's going to change. Each invocation of program is going to change the address. But you can see last 3 digits 930. Okay. Then B is at 1 byte more than the address of A. So I take address of A, which is stored here, add 1 to it, and dereference that, then I get B. Okay, this one prints B. And when I simply print str plus 1, which is 1 more byte than address stored in str, then I print address of B, which is this one. This was the address of A, right after A is the address of A, right after B is the address of B. And this is just 1 more byte. You can compare these two numbers. This is 1 byte more than that one. Proving, of course, character is 1 byte. Okay. And same way, you can pause the video and see rest of the code and its output. Okay, I can go just a little bit more. Yeah, actually now we have everything. So we got A, address of A. Address of A was gotten by dereferencing str. Address of A was gotten just by printing str itself. B was printed by dereferencing str plus 1 because that's 1 more byte where str is. And then printing content of str plus 1 got us the address of B. And same way we got C, which came from here. We got address of C, which came here, from here. We got address, D, and we got address of D, this one. And notice this didn't print anything because at 4, 0, 1, 2, 3, 4 is null terminator, which is not printable. Nothing got printed in this line, but address of the null terminator did get printed by this line to be here. Okay, A was 0 byte 0, 1, 2, 3, 4. If you look at our picture, 0, 1, 2, 3, 4. 1 byte each. So that's how the indexing sort of C strings is done. Later on when I teach you arrays, I would simply replace this +1 by str square bracket 0, 1, 2, 3, and you'll see the same effect. And I could also do not 1 but plus 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 plus. That'll work the same way. This is called pointer arithmetic. There are 3 or 4 different ways to do it. I'm not going to get into other ways right now. You might get confused. So that's how character array works. You can take a character string, sorry, C strings work. They are of course character array. C strings work like that I can take a C string, char pointer, have it pointing to a C string, and it can just print it using this syntax right here, right there. But if you want to print each individual character, then you can do dereference pointer to each character, and you can print address of each character too. Now getting to the function. So let me comment all this out, so this is not in our view. And just use this print function. So let me show you this print function. It's very simple actually. This is print function. I'm passing it a character pointer, which is pointed to a string. A string could have 1 character, 0 character. A string could have 0 character, by the way. Those are called 0 length string. Or it could have 10 million, doesn't really matter. It's limited only by the amount of memory operating system is willing to give you. So since it is pointing to a string, and I would make sure that happens, format string s, and I can print that my news is a string character. In this case, I only have ABCD stored. So when I pass this to this function call is made here, void function. Prototype is right here. And function definition is very small, right here. It should print ABCD. And let's see. It actually did ABCD. It printed that string to which str was pointing to. Okay. All right. Clear? Now you must be saying, Dr. Singhal is saying, we're going to show you passing large blocks of memory to a function. Hasn't done that. I'm ready to do that now. For that, what I'm going to do, I'm going to rename this main as main2. Fold it totally so it's automatic. Okay, why did I get the compiler? Maybe return 0 is missing. Yeah. 0. And then I'll have main1 here. Main here, I'm going to code that one in and fold that one out of your view. Let's look at this main. It's very interesting. So notice here, okay, let's do this. Let's do this. Here I took a piece of news from New York Times and stored that into this string. Notice this is character pointer pointing to, in this case, C. And since everything is 1 byte, I can have access to every byte in the string, really. And anyway, if you have time, you can pause the video, read the news. This is the news from New York Times about how Russians hacked American power plants, or at least tried to. In C string, you can hard-coded C string, you can type as many lines as you want, but after each line break, you have to put this slash, and that will be considered a continuous string. So up to here is a continuous string, okay? And then I'm passing this pointer to print function that we have used before. Copy of this address is copied here, and then I can print this. So here is a huge block of memory, this being passed to this function without making copy of this block of memory. That's the example of passing a large block of memory to a function. And notice during execution of the function, only 4 bytes are added to our memory overhead, because when I make copy of this pointer into this, I've just added 4 bytes. This could be 30 megabytes. It's not going to matter because we have access to this through its pointer. That's only 4 bytes. That's the huge advantage of using pointers when we need to pass large block of memory to a function. Okay. Now I'm going to show that this works. It's going to print this entire news, actually better formatted than this. But what I need to do this, I need to show this to you in terminal. Let me first compile it actually. And over here is going to look kind of bad, but terminal can give me a better formatted version. You could run any C program through terminal on Xcode. All you have to do is go to this products and take this product, drag and drop here. Now click enter and the function program will be executed. And now you can see cyber attacks put Russia fingers on switch at power plants, USA's, blah, blah, blah. It's nicely formatted, okay? Pretty much the way it was formatted in New York Times. Here is the example that a large block of memory was passed to a function, huge amount of block of memory, but it costs us only 4 bytes. Okay? That's the big advantage of passing data through pointers to functions. You can pass large blocks of memory. It's not going to have memory overhead. It's not going to kill the battery in the telephone. Very, very efficient mechanism of passing data. Okay? So in this case, we're going to stop here. There will be other examples of passing large blocks of memory, like arrays, structures, things like that, structures and records. And we'll keep pointing them to you as we go along. In this series, I do want to do one more video about very special property of swapping data through the pointers. And that plus a couple of other things may be the last few videos in this series of user-defined functions. Once again, this is Dr. Satish Singhal, PhD, Professor of Computer Science at El Camino College, Torrance, California, saying goodbye.